Hello everyone, welcome to proChem Academy. Today we will discuss study of compounds HCl. Now already I have uploaded one video on HCl. I think you have seen that video. The link of the video will be given in the description box. Please see that video. And if you like that video, then do like, comment and subscribe my channel. Now here we will discuss the second part of the HCl. It will be second video on hydrochloric acid. Now we have seen that in the first video that sulfuric acid we can dye the hydrochloric acid, hydrogen chloride gas formed by the laboratory method by sulfuric acid. So other drying agent we are not used in that. That means calcium oxide and phosphorus pentoxide we have not used as a drying agent of hydrogen chloride gas. Now what is the reason behind that? Why calcium oxide and phosphorus pentoxide is not used? Okay, why calcium oxide and phosphorus pentoxide is not used as a drying agent of HCl, that means hydrogen chloride gas. Why? Because calcium oxide will react with hydrogen chloride to form calcium chloride and water. That's why it cannot be used. Okay. So what is the reason? Calcium oxide will reacts with HCl to form calcium chloride and water. Okay, and so as again phosphorus pentoxide, it is calcium chloride. Okay, so as phosphorus pentoxide reacts with HCl to form phosphorus oxychloride POCl3 and metaphosphoric acid. So after that you have to balance this one. So this is the reason behind why you have to write in word also. If the examiner asks you why we cannot use for calcium oxide and phosphorus pentoxide, you have to give these two reactions. You have to say the reason that because phosphorus pentoxide reacts with HCl, it will react with HCl. So why will use? Will not use. We cannot try like this. Okay. So this question is important. So copy this one. Now we will discuss the fountain experiment of HCl, and it is very important. The fountain experiment of HCl. HCl can make the one experiment is there from which we know that HCl can form fountain like ammonia. So fountain experiment of HCl. This is very important and this is very colorful experiment. What you have to do, the HCl gas we have prepared by the laboratory method or by reacting sodium chloride with sulfuric acid. We have got sodium bisulfate, and with that sodium bisulfate we have got with that HCl. So here that HCl, okay, that HCl can be taken part in the fountain experiment. Okay, so we have to take a stand, iron stand, and there we have to keep a round bottom flask like this. We have to keep here a round bottom flask. Okay, we have to keep a round bottom flask. Okay, we have to clamp this one, the round bottom flask. Now this round bottom flask will not place like this. We will place in opposite direction like this. We will place a clamp will be there like this, and here we will put a round bottom flask. This is the round bottom flask. Now in this round bottom flask we'll have a cork. Okay, this round bottom flask will be fitted with a cork, and we'll have a two stopper hole. Okay, two stopper will be there, and in one stopper, that means one hole, will take one long jet tube. Okay, and in another stopper we will take one inject. That means injection or injection series we can take. Injection series we will take. Okay, now this stopper, this long jet tube will be dipped into a solution of blue litmus. Will be dipped in the solution of blue litmus. This will be blue litmus. Now you know that litmus is an indicator that tells us that which one is acid and which one is base. Now what we have taken? We have taken a blue litmus here. Okay. Now in this round bottom flask, we have taken HCl, dry HCl gas. Here we have taken dry HCl gas. Here we have taken dry HCl. Okay. Now this one is a dropper or a syringe, whatever you can say. This one is dropper or syringe. Now what we will do? Here we will push this syringe, and it will be water will be here. The syringe will be filled up with the water, or this dropper will be filled up with water. Now we will push this dropper or syringe, so that we'll add here water. Water will be added here. That means we'll push the water here. Now we know that HCl is very much soluble in water. So what will happen? All the dry HCl will be soluble in this water. So vacuum will be created here. This upper portion will be vacuum. Now to maintain the pressure, that is low pressure will be created here at the upper portion. Now to maintain the pressure, the blue litmus solution will go up into this water to form a red color solution. Means why? Because this we know that HCl acid turns blue litmus into red. Acid turns blue litmus into red. That's why we will get a red fountain here. I don't have a red pen, that's why I cannot show, but we will get a red fountain. So what is the reason behind why this litmus solution is going upward direction? Because here low pressure is created. And why? Because HCl is dissolved in water. Okay, and to neutralize that low pressure, to fill up that low pressure, the indicator, that means this blue litmus solution is going upward direction. Okay, to form a red color fountain. Okay, so this is the fountain experiment of HCl, and this experiment can be done in any kind of exhibition, chemistry exhibition in school or in college also. Okay, so it is very important. Draw this. Now we will discuss the reactions of HCl, hydrogen chloride. Now we know that hydrogen chloride is a gas, but the solution of hydrogen chloride gas is the hydrochloric acid. So same reaction will be done by the HCl gas or hydrochloric acid. HCl, when it is liquid state, it is hydrochloric acid, and when it is in gaseous state, it is hydrogen chloride gas. Okay, so hydrogen chloride is the gas, and hydrochloric acid is the solution of hydrogen chloride gas. Okay, so reactions of hydrogen chloride. HCl. Now first reaction is that when HCl reacts with a metal, it forms metal chloride plus hydrogen gas. Okay, metal plus HCl, it forms metal chloride plus hydrogen. Okay, so this is the method. So what is the reaction? Metal, that means Mg plus HCl to form magnesium chloride plus hydrogen. Now if you want to balance, you can balance, multiply by 2. Another metal Fe plus HCl, it will form ferrous chloride plus hydrogen. So this is the first method for the reactions of HCl. Now second method, metallic oxide plus HCl. Okay, it will form metal chloride. It will also form metal chloride with water. Now metallic oxide, you can take potassium oxide or sodium oxide, you can take also. Potassium oxide is K2O plus HCl. It will form KCl plus water. Okay, multiply this one by 2, multiply this one by 2. So it is balanced. Then sodium oxide also you can take. Okay, now these two reaction done. Now next, when hydroxide means ammonium hydroxide or sodium hydroxide, that means a base or an alkali reacts with acid, it will form corresponding chloride salt. That means with HCl it will form corresponding chloride salt, and with that water. Okay, so next is that your metallic hydroxide plus HCl to form metal chloride. Metal chloride, not metal chloride. Not normal hydroxide. Okay, hydroxide plus HCl, it will form salt plus water. You can say this kind of neutralization reaction. Say sodium hydroxide reacts with HCl, it will form sodium chloride plus water. Okay, same thing, ammonium hydroxide plus HCl, it will form ammonium chloride plus water. So these are nothing but kind of neutralization reaction. Okay, next is very important, when metal carbonate like copper carbonate, sodium carbonate reacts with HCl, it will form corresponding chloride, water and carbon dioxide. That carbonate will be evolved as carbon dioxide. Okay, so what is the main method? That metallic carbonate or metal carbonate, or you can say metal bicarbonate. Okay, metal carbonate plus metal bicarbonate plus HCl, it will form metal chloride with water with carbon dioxide. Clear? Now see the reaction. Metal carbonate means Na2CO3 reacts with HCl. What it will form? Metal chloride. That means NaCl plus H2O plus CO2. To the balance you can easily do. In the both sides the number of atoms will be same. Okay. Next K2CO3 will take plus HCl. What will form? KCl plus H2O plus CO2. Bicarbonate will take, okay, sodium bicarbonate NaCO3 plus HCl. What will form? It will form NaCl plus H2O plus CO2. Now what is the difference? You have to do the balance. Okay. Now when you are taking metallic sulfide, that means Na2SO3 or NaHSO3, and you are treating with HCl, you will get sulfur dioxide. When metallic sulfide is there, okay, and if it is sulfide is there, you will get H2S. Okay, first of all you write these things, after that I am writing those reactions. Okay, copy this. Next is that what? That metal sulfide means sulfide, we know that metal sulfide is K2SO3, metal sulfide, because sulfide is SO3 minus 2 ion sulfide. This metal sulfide when reacts with HCl, same thing, this sulfide will form sulfur dioxide gas, water will be there with the metal chloride. Simple reaction. Okay, if it is metal hydrogen sulfide, that means metal bisulfide with HCl, same reaction will be there, but difference is that they are balancing. So balance you have to do by your own. Okay, you will do it. Next is that sulfide bisulfide done. Now if it is sulfide, if it is metal sulfide, metal sulfide means what? Metal sulfide means it is sulfide, H2 minus ion. So say Na2S, it is a metal sulfide, sodium sulfide, reacts with HCl. What it will form? It will form NaCl plus H2S. This H2S is called hydrogen sulfide gas. to form metal sulfide plus HCl, that means HCl, what will form? Metal chloride with H2S. Same reaction, copper sulfate, this is very important reaction, plus HCl, it will form copper chloride plus H2S. Now we have more reactions, sodium with sodium thiosulfide with HCl, potassium permanganate with HCl. So those reactions we will do in next class, in the third video of this HCl, and in that video we will start the ammonia. Okay, so today's video is up to this. If you like this video, then do like, comment and subscribe my channel, and please hit the bell icon so that whenever I upload the video, you will get the notification. Thank you.